One number is 5 units greater than the other. 3 times the greater plus twice the smaller is equal to 30. Determine the numbers. Well, we don't know what those numbers are. I'll represent the smaller one. Here, I'll represent the smaller one by x. The greater one, pay attention, if one number is 5 units greater than the other and the smaller is x, the greater will be x plus 5, okay? And 5 units more. Well, now that we have both numbers, the smaller is x, the greater is x plus 5. Going back to the problem, 3 times the larger number, here, the triple of the greater one. If the greater one is x plus 5, the triple of the greater one will be 3 times the quantity x plus 5. Added to the double of the smaller one, wait, the smaller one is x. So the double of the smaller one will be 2x plus 2x. That is equal to 30. Cool, we've set up the equation. Solving this equation, notice that the 3 multiplies everything inside the parentheses. 3 times x and 3 times 5, it's the famous distributive property, also known as the little shower method. 3 times x is 3x, plus 3 times 5 is equal to 15. Plus 2x, I'll repeat, all of this is equal to 30. We have like terms here. 3x and 2x, we can add them. 3x plus 2x is 5x. So 5x plus 15, we can move it to the other side of the equation by subtracting. So it will be equal to 30 minus 15. All right? 30 minus 15, we can solve that. So continuing here, 5x will be equal to 30 minus 15, that's 15. 5x is equal to 15. Since x is being multiplied by 5, we move the 5 to the other side by dividing. So, continuing up here, it will be like this. X equals 15 divided by 5. Solving this division, 15 divided by 5 is 3. So, we conclude that x equals 3, and that's exactly the smallest one here. We didn't represent the smallest one with x. So, I'm going to write here the smallest one is equal to 3. And the largest one is x plus 5. So, the largest one will be 3 plus 5. 3 plus 5 is 8. I'll write it here. Let me erase this. I'll write it here. The largest one is 8. So, the numbers are 3 and 8. Who got this? You got the problem right. Awesome, right? If you solved it differently, let me know in the comments. We've reached the end of another explanation. If you liked it, please like the video to support Professor Robson Lyer's channel. If you haven't subscribed yet, I invite you to do so. And don't forget to share it on social media with your friends, okay? Professor Robson Lyer sends a big hug and hopes to see you next class.